Python removal is nothing new here in the Sunshine State, from the work of Florida Fish and Wildlife to the annual Python Challenge. But now the state has teamed up with another partner.
Florida once faced a shocking problem deep in its wetlands. Invasive Burmese pythons were multiplying fast and destroying the ecosystem. But what the state tried next left experts stunned. Millions of mice were reportedly released into the wild as a desperate plan to fight back. The idea sounded bizarre, almost unbelievable. Could tiny rodents really disrupt giant predators already ruling the swamps? What happened afterward was something no one predicted. Join us in this video as we reveal the details. The outcome would spark debates, confusion, and disbelief across the country and change wildlife policy forever in Florida and history lessons, the mousetrap experiments that changed the conversation. Back in the 2000s, the USDA's National Wildlife Research Center tested a strange idea in Guam. Biologist Bryce Ohashi helped lead some of the earliest large-scale trials. The plan was simple in theory. They dropped about 2,000 baited mice into selected jungle areas where snakes were a problem. What happened next surprised many people. In areas where the mice were dropped, snake numbers dropped by as much as 80% in a single operation. Later, bigger efforts pushed the idea further, with up to 30,000 baited mice released across wider forest zones known for heavy snake activity. It was simple, low cost, and far more effective than traditional trapping or hunting. Even more surprising, researchers later found that Burmese pythons share a weakness with brown tree snakes. Studies from the University of Florida showed they are vulnerable to acetaminophen, the common painkiller in Tylenol. This led to a bigger question: why not use it in Florida? The answer lies in biology few people discuss. But did those experiments really solve Florida's python problem? Keep watching to find out. The numbers that broke the old strategy. Let's start with the numbers, because the numbers are what broke confidence in old solutions. Since 2017, state agencies and licensed hunters have removed more than 10,000 Burmese pythons from Florida's wild. The annual Python Challenge, a state-sponsored event that brings hundreds of hunters from across the country, still only takes out about 100 or 200 snakes per competition. Government contractors work year-round. Private hunters move through levees at night with headlamps and bare hands, and even then, it barely makes a dent. Nobody really knows how many Burmese pythons are still hiding in the Everglades. Estimates range from tens of thousands to numbers officials avoid saying out loud. What most models agree on is simple: the snakes are reproducing faster than they are being removed. A single female can lay up to 100 eggs in one clutch. They don't behave like normal wildlife. They behave like ghosts in the sawgrass. These snakes came to Florida through the exotic pet trade. Small hatchlings were bought easily, then released when they became too hard to handle. That happens quickly when a 2-foot pet turns into a 16-foot, 165-pound apex predator that can swallow deer whole. Scientists have found intact deer remains in python stomachs, including hooves and antlers. Raccoon populations in parts of the Everglades have dropped by 90%. Opossums, rabbits, and nesting birds are disappearing too. Every animal becomes the same question: can it fit inside? The Everglades give them everything they need: thick vegetation, warm water, and no winter to slow them down. It is one of the most python-friendly environments outside Southeast Asia. But every removal strategy hits the same wall. You cannot hunt what you cannot find. You cannot trap a predator that does not rely on bait. And you cannot poison a snake without harming everything else in the water. So researchers began asking a different question: not how to hunt them, but what if the food itself could be made lethal? And they got their answer. Why was the idea to drop mice from the sky really adopted? Let's find out. The island that lost its birds and found a strange answer. To understand why they were dropping mice from a helicopter, you have to go back about 8,000 miles to a small island in the western Pacific that lived through its own version of this disaster decades earlier, with no plan and almost no way out. In 1952, a brown tree snake arrived on Guam inside military cargo. At first, it seemed harmless, about a meter long, mildly venomous, and not aggressive toward humans. Early wildlife observers barely paid attention to it. There was no reason to think it would change anything. But Guam's birds had evolved for thousands of years without ground predators. They nested low, laid eggs in open areas, and never developed fear of anything climbing toward them. No alarm calls, no escape behavior, no survival instinct against snakes. For the brown tree snake, the island was not a challenge. It was an open buffet. Dr. Julie Savage, then a graduate student at the University of Illinois, arrived in Guam in the early 1980s to understand why the birds were vanishing. At first, people blamed pesticides or disease. Then she began finding eggs destroyed in abandoned nests. She later recalled standing in a forest that should have been full of bird calls, hearing nothing at all, and seeing a brown tree snake at her feet. That was when she understood what was happening. Her 1987 paper in conservation biology shocked researchers. By then, it was too late. Scientists recorded up to 5,000 snakes per square mile. 12 bird species stopped breeding entirely. 8 more lost over 90% of their populations. Entire cultural traditions tied to birds began to disappear with them. And the damage didn't stop in the forest. Brown tree snakes climbed power lines, causing about 200 outages a year. The economic losses reached millions, but the deeper loss was the collapse of the island's natural balance. Savage's work sparked urgency across the Pacific. If it could happen here, it could happen anywhere. That search for a solution eventually led to something unexpected. Acetaminophen, the active ingredient in Tylenol, is deadly to these snakes. A small dose can shut down their liver. And that opened the door to a strange idea. You cannot scatter pills in a jungle, but you can hide 80 milligrams inside a dead mouse, attach it to a canopy streamer, and drop it from a helicopter. But could this strange solution really target only young snakes? Stay tuned to find out. The juvenile window and the hidden risk. Adult Burmese pythons are simply too large for this strategy to work directly. A full-grown individual at 16 feet and 165 pounds is not hunting mice. A mouse is irrelevant to an animal that eats deer. But what makes the mouse drop strategy potentially viable in Florida is a detail documented by University of Florida herpetologist Dr. Kristen Hart. Juvenile Burmese pythons, hatchlings, and young snakes in their first 1 to 2 years are completely different from adults. At that size, roughly comparable to adult brown tree snakes, mice are exactly the right prey. Juveniles actively hunt small rodents, and crucially, they climb. Unlike large adults that spend most of their time in water or dense cover, young pythons move through low branches and vegetation. Hart has tracked dozens of juvenile pythons in the Everglades using radio telemetry. Attaching tiny transmitters and following their movement through terrain humans can barely walk. The young snakes behave differently. She described them as explorers, constantly moving, constantly climbing, searching for opportunity. That behavioral detail is the foundation of the entire idea. The bait is designed for the juvenile stage, and the juvenile python is biologically wired to hunt exactly that kind of prey. This is why researchers believe the approach might actually work at a specific point in the snake's life cycle. Here is the key math. A female Burmese python does not need to survive to adulthood to impact population collapse. You only need to prevent enough juveniles from reaching reproductive age. If enough young snakes are removed consistently over enough years, the population stops replacing itself. The strategy is not about unaliving today's snakes. It is about ensuring there are no snakes 10 years from now. To cover the Everglades and surrounding regions, researchers estimate millions of bait drops would be required each year, not thousands. The scale Marcus Reyes was working toward that morning over Alligator Alley is almost impossible to imagine. And here is the catch. Once millions of acetaminophen-laced mice enter a biodiverse ecosystem, control over everything that consumes them is lost. This is where the story shifts from innovation to risk. The Everglades is not Guam. Guam had already lost most native bird life when intervention began. The Everglades still supports hundreds of bird, reptile, mammal, and fish species, all tightly connected. Acetaminophen does not only assassinate python, raccoons, and opossums, already reduced by nearly 90%, would face additional pressure. These animals are also rodent consumers. A poisoned mouse becomes an easy meal for them. Secondary poisoning is the real concern. A squirrel eats a contaminated mouse and survives briefly, then is hunted by an owl. The residue moves up the food chain. Raptors feeding chicks may pass on the toxin without knowing it. Every link in the Everglades food web is interconnected. Removing one species or introducing a toxin creates unpredictable cascading effects. Even species not directly targeted may experience population stress through repeated exposure. Birds of prey such as owls, hawks, and eagles may occasionally consume bait indirectly. Adults might survive low doses, but chicks are far more vulnerable. Effects would not appear immediately, but in long-term breeding data. Yet the most unexpected risk identified in modeling was not birds at all. It was domestic and feral cats living near human edges of the Everglades system. We are talking about a scenario where a single overlooked behavior ripple could reshape entire populations. Cats sit at the intersection of wild and human environments, and in South Florida, they are everywhere along canals, suburban edges, and abandoned structures. Unlike raptors, cats are highly adaptable, opportunistic feeders. If a poisoned mouse appears in grass or shallow water, a cat will almost certainly investigate. The concern raised by researchers is not just acute toxicity, but accumulation over repeated exposures, especially in feral populations that cannot be monitored easily. This creates a feedback loop where unintended consequences become statistically invisible until they are ecologically significant. The Everglades already operate under pressure from water management, invasive species, and climate variability. Adding another chemical vector into that system raises questions that extend beyond pythons into the stability of the entire ecosystem and the long-term resilience of its native species. The debate, therefore, is not only about effectiveness, but about proportionality, whether a targeted solution can remain contained within such an interconnected landscape without triggering secondary collapse patterns that mirror the original invasion problem. In that sense, the mousetrap strategy becomes less about control and more about managing uncertainty in one of the most fragile ecological systems in North America. Ultimately, researchers caution that every intervention carries trade-offs. And in environments like the Everglades, those trade-offs can unfold slowly, silently, and across generations, making early warning signs difficult to detect until irreversible changes have already taken hold in ways that often appear only in hindsight, when ecosystems have already shifted beyond recovery thresholds, requiring far greater effort to understand and potentially restore. What happens when the solution threatens Florida's rarest predator? Let's find out. The 120 panthers in the crossfire. Nobody talks about 120. That is the lowest credible estimate of how many Florida panthers are still alive in the wild. Just 120 animals, the entire surviving population of a species that once spread across the American Southeast, now compressed into the southwest corner of Florida, trapped between highways, development, and the Everglades itself. This is the same landscape where millions of acetaminophen-laced mice could be falling from helicopters. Florida panther conservation biologist Darrell Land has spent more than 3 decades tracking this population for the Florida Fish and Wildlife Conservation Commission. He knows most of the surviving adults through radio collar data. Some he has followed since they were kittens. He can recite the ID numbers of the ones he has lost to territorial fights, vehicle strikes, disease. When he talks about the math, there is a flatness in his voice, the tone of a man who has run this calculation too many times and still does not want the answer to be what it is. For cats, acetaminophen is among the most acutely dangerous compounds in existence. Their livers lack the enzyme pathway that allows human bodies to process it safely. Even small doses cause hemolytic anemia, the destruction of red blood cells. Liver failure follows. The dose that might produce temporary illness in a 30-pound raccoon can unalive a 130-pound panther. Florida panthers are apex predators, but apex predators are also opportunists. A dead mouse caught in low branches represents zero energy expenditure, zero risk, and free protein. That is exactly the kind of effortless meal a large cat takes without deliberation. Panthers scavenge and investigate unfamiliar scents. They move through exactly the terrain where bait drops would be concentrated, near water, at the ecotone where swamp meets sawgrass. Picture it, a Florida panther, one of 120 left on Earth, moving through scrub at dusk. It finds a dead mouse caught in low branches. It consumes it in 3 seconds and walks away already dying. No way to know it. Daryl Land has described losing even 2 or 3 individuals to a bait campaign as something the population cannot survive. There is no buffer, no reserve. The panther risk assessment for the mouse drop strategy arrives at the same conclusion in every version. The intervention cannot be deployed within or adjacent to active panther range without unacceptable risk. And panther range and python range overlap almost completely in South Florida. There is one more animal this program would reach, one you have probably never heard of and one that may matter more to Florida's ecosystem right now than almost anything else in it. Keep watching to find out what animal it is. The indigo snake problem and the blind spots in the plan. The eastern indigo snake is the longest native snake in North America. It is also one of the only animals in Florida that will actively hunt and unalive juvenile Burmese pythons. It pursues them, it eats them. It is the biological control that should be keeping python numbers in check from within the ecosystem. But its population has been collapsing for decades due to habitat loss and fragmentation. Today, expensive conservation programs are trying to rebuild indigo numbers through captive breeding and reintroduction efforts. The eastern indigo snake also eats mice. That is where the concern begins. If bait drops happen in the Everglades, indigo snakes will encounter them. Whether they have any resistance to acetaminophen is completely unknown. No large-scale testing has been done. The risk exists, but it is unmeasured and largely absent from public debate. There is another structural issue with aerial deployment. It is not precise. A significant portion of bait mice would inevitably fall into water. Burmese pythons are semi-aquatic, so bait must be dropped near wetlands, lakes, and slow-moving rivers. That means fish will consume some of the bait. It also means aquatic food chains absorb the compound in ways that cannot be easily tracked. 3 days after the first test drop, Reyes is back in the field. This time he is on the ground, wading through shallow water toward a trail camera strapped to a cypress knee south of Alligator Alley. The camera has been running for 72 hours. He loads the footage on a rugged laptop and begins reviewing it frame by frame. What he sees is not what the program was designed to capture. An opossum appears first, sniffing at the bait. A raccoon follows roughly half an hour later. A great egret stands in the frame for a long time, staring upward into the trees. No juvenile python appears at this site within the recording window. He logs everything carefully: species, timestamps, behavior. Then he moves on to the next location. This is the part of the program not shown in reports. The learning phase where every species in the ecosystem starts interacting with the bait in ways nobody fully predicted. Florida has not experienced this exact calculation before, but it has seen what happens when large-scale ecological interventions collide with public scrutiny and uncertainty. Would the public ever accept such a controversial intervention? Let's find out. When public trust collides with ecological engineering. In the early 2020s, the biotech company Oxitec received approval to release genetically modified Aedes aegypti mosquitoes in Monroe County, Florida. The science behind it was straightforward. Modified males were designed so their offspring would carry a self-limiting gene, causing the next generation to die off before reaching adulthood. No chemicals, no spraying, just a population collapse from within. The results elsewhere were hard to ignore. In the Cayman Islands, similar releases reduced mosquito populations by around 80%. In parts of Brazil, longer deployments reached reductions of up to 95%. On paper, it looked like a clean solution to a real public health problem. But in Florida, the reaction was anything but calm. Residents showed up to public meetings holding signs that read, "Franken mosquitoes." Lawsuits were filed. Community forums turned into shouting matches. Even when studies, including one from Yale, suggested only limited and context-dependent genetic persistence in wild populations, the debate had already moved beyond the science. The headline had done its job faster than the data could respond, and that was just mosquitoes. Now imagine the announcement is not about insects, but about millions of bait mice laced with a common painkiller, dropped from helicopters into the Everglades. An ecosystem where raccoons, panthers, eagles, indigo snakes, and dozens of other species move through the same water lines and tree edges. Even before deployment, the questions would stack up. What happens when a domestic dog finds one of these bait mice near a residential boundary? What happens when a child does? What happens when species outside the target zone begin interacting with the bait at scale? There are no simple answers that would satisfy public concern in real time. What do you think of this method? Let us know in the comments section below. In the end, this story shows how complex solutions rarely come without hidden costs or unanswered questions. Whether Florida ever finds balance with its invasive species, problem remains uncertain. If you enjoyed this, like, subscribe, and stay tuned for more stories that go beyond the headlines.